All right, so today we're going to talk a little bit about section 2.2, which is on linear scatter plots and linear models. Okay, so we're going to be taking data. We're going to be building a linear equation based on that data. Okay, this is a very practical skill. Like linear equations are we have to start somewhere, so they're kind of simple. But this modeling idea is something that just about every business in the world does, especially bigger businesses. Let's just predict what's going to happen in the future, and it's very practical. So it's a good skill to learn. We're going to use a lot of technology today, but before we get into the technology side of things, it's important that we understand what we're looking for here. So what we're looking for in this lesson are behavior of our points that are generally linear. They look like straight lines. And so if I have a scatter plot like this, where I have a distinct turning point, that's what we call this up here, where it switches from increasing on the left to decreasing on the right, doesn't make a lot of sense to use a linear function. Any line that we draw through here is not going to represent the data very well at all. So this is just something we would not want to use a linear regression on. We are going to learn other forms of regression later in the course that would be appropriate for this, but linear just wouldn't be a very good choice. Now, this one, on the other hand, is pretty much perfectly linear. These are very, very close to a straight line already. Okay. And so a linear regression would be very appropriate here, but this is not very realistic. In the real world, you very, very rarely get points that line up perfectly like this. So I would say that this is more what a kind of a standard data set that would be appropriate to model with linear equation would be. There's in general, this graph is increasing in value. These points are increasing in value as we go from left to right across it. And I can kind of draw a line in here somewhere that does represent the data fairly well. I can draw a few points above, a few points below. Makes a lot of sense. So I would say that both of these two graphs are appropriate to use a linear regression on, because in general, the data set looks kind of like a straight line. It's increasing over time as we go from left to right. It could be decreasing over. It just needs to be consistent. We don't want any turning points like we had in this first one. Okay, so next, let's take some data here. We've got a table with some X values and some Y values in them. Let's use this table to make a scatter plot. Then we'll talk about whether it's a good linear regression candidate, and then we'll do a linear regression on this data and see what it looks like. So what I'm going to do here first is I'm going to type my data into the calculator. So the way that we're going to do that is we're going to go into the stat menu here, right in the middle of the second row from the top here. I'm going to go into stat, and then I'm just going to go into edit here. Okay. And you might have some data in here already. If you do, what you want to do is you want to go up to L1, hit the clear button, and then hit down. That'll clear it out. You don't want to use the delete key in here. That will lose the whole list, and then you'll have to go reset it up again. It's kind of a pain. So I would avoid that whenever possible. Just highlight the list, hit clear, and then hit down. And then once we've got this in, what we're going to do is we're going to type our X values in L1. Okay, so 1, 3, 5, 7, and 9, just hitting enter between each of them to get down to the next row. Okay, then I'm going to go over to L2, and I'm going to type the 7, 11, 16, 21, and 27 there. Okay. So once we have our data in L1 and L2, just take a quick second to make sure your lists are the same length. If our lists are not the same length, we're going to have problems for sure. If you skip a value, especially when your lists get longer later in the course, you just want to make sure you've got all those things in there. You have the same length. Double check for typos and all that too. You just want to have it set up correctly. Okay. So once we've got that ready to go, the next thing I'm going to do is I'm going to make sure my stat plot is on. So I'm going to hit second and then Y equals. And then I'm going to hit enter on this stat plot 1. If this is off, which it probably will be for you the first time, you want to make sure you turn it on. Okay. And then the rest of this, you don't have to change very often. Like we want it. This is a scatter plot. That's what we want. And then our data is in L1 and L2. So you shouldn't have to change anything here. So make sure it's on. Okay. And then our next step is to zoom in on where the data is. Now, one nice feature of the calculator is it has a very easy zoom function for these kinds of problems. It's called zoom stat. It's going to zoom right in on the data that's in our stat menu that we just put in. So I'll just go down here, choose zoom stat. Okay. And there is my scatter plot. And I would say that this scatter plot looks quite linear. It's increasing as we go from left to right, straight line, no turning points that are really going to mess me up. So definitely appropriate to use a linear regression here. Looks like a straight line. Okay, so once we've made that decision, we're going to go ahead and do our linear regression. So I'm going to go ahead and quit out to the main screen. I'm going to go into stat. And then this time, what I want to do is in the calc button. So I'm hit the right arrow to get over to the calc menu. And then linear regression is just number 4 in the list here. So I'll just either hit 4 or scroll down to the 4 option here. Okay, it's going to ask me for some information. My X and Y lists are in L1 and L2, so we'll leave those where they are. And then one thing that I'm always going to do is I'm going to come down here to where it says store regression equation. I'm going to go ahead and have the calculator put our model that we get into our graph as well. So in order to do this, and this is just a good habit, I would always do this when I'm doing a regression. We're going to go into vars right over here. Hit right to go to yvars, and then just hit enter twice, enter on function, and then enter on y1. And what this will do is it'll take the equation that we're going to come up with, it'll put it into y1 in my y equals menu automatically. Then I'll just choose my calculate option here. And we've got it. So to answer the question, to get the linear equation, it's going to look like this. Y equals 2.5x plus 3.9. Okay. You'll notice if you go into the y equals menu, because I put that y1 in there, it's dropped that into y1 for me here. Okay. And if I go into my graph, I'll see my line running up through those scatter plot points that we were working with before. Okay, so we will certainly be using these regression equations later in the course. And so we'll want them in the graph as well, because that will make it much easier to work with. Okay, so let's look at one more linear regression problem that's a little more involved. In this one, again, we have a table. It says that this is the percent of adults with diabetes based on different years. And it asks us to find a linear model that fits the data in the table with X equals 0 for the year 2000. Now, we've seen this before, but it is something that we always want to be paying attention to. The last thing that you want to do is put 2010, 2015, 2020 in for X. 0 is the year 2000. So really, we're going to be doing 10, 15, 20, 25, 30, 35, so on. And this is, again, extremely common in this class and extremely common in the real world. We don't want to be putting 4-digit X values in to our equations. We want to be, we call this, we base our starting year as our year 0. Aligning the data is what we call that often. Okay, so let's go ahead and start by putting this data into our calculator. We're going to do it the same way we did in the last problem. We're going to go into stat and then choose edit. And again, you're probably going to have data here from the last problem, so you need to get rid of it. So again, highlight your L1, hit clear and then down. Highlight your L2, hit clear and then down. And then we're going to type our X values in L1. Don't forget that we've aligned the data. X equals 0 for the year 2000. So this is going to be 10, 15, 20, 25, 30, 35, 40, 45, and 50 for our X values. And then we're going to go over to our L2 column, and we're going to put our Y values in there. So 15.2, 18.2, 19.5, 24.5, 27.8, 29.0, 31.7, 33.9, and 34.3. Whoops. Okay. Whoops. Oh, I see. And you'll notice I made a little typo here. This is something that happens. You need to be able to adjust for it. The reason why I knew immediately that I'd made a typo is my two lists are not the same length. If my two lists are not the same length, this is just not going to work. So it's something that you always want to check. I'm glad I made this mistake. It's a good example of why you always want to be looking for that, because it's an easy mistake to do. I just put this 0.9 on the wrong line here. So this is going to be 34.3. And then we'll just delete this one row out. Well, we'll just sorry, I have to type this again. My mistake. 24.5, 27.8, but it is a good example of why you want to make sure that you are double checking the length of your tables. They need to have the same number of entries on both lists, or else we'll have problems. Okay, and so now my lists are the same length. We're in good shape. So we're going to go through the same process we did the last time. We're going to find our linear model. So we're going to quit out to the main screen. Okay, we're going to go into the stat option here. We're going to go right over to calc. Okay, and then we'll choose our linear regression. Okay, and I'm going to go down to store regression equation. I'm going to put it into Y1. We're actually going to be using it later in this. So we definitely want this in our Y1 option. So I'm going to go into vars, hit right to go to YVARs, and then just hit enter twice to put this into Y1. Okay, so we'll go into our calculate now, and this will be our model. And you do want to pay attention to the rounding instructions. And this one, it does say to round to 3 decimal places as needed. So we don't have to round the first time. So it's going to be like 0.508 times X. We do have to round the second one. So it'll be 10.771. Do need to make sure we're rounding appropriately. Okay. And so then, we've got our data into Y1 as well. Let's put that in there for us automatically as well. Okay. So now what we need to do is we need to put these values in. It says to use the model to predict the % of adults with diabetes in 2027. Okay. So this 2027 is an X value, but remember, X is the number of years after 2000. Okay. So we really want to plug 27 into this equation. Now, this is where putting that into Y1 is going to be really handy, because watch how easy this is. I want to plug 27 into this function. All I've got to do is go vars, YVARs, function Y1, just to get that, just like I did before, and then just put 27 in there. Okay. In parentheses. This will just plug it into our equation, and we've got it. So 24.5 will be our percentage there. So very, very quick and easy. We could, of course, have just, worked it out. 0.508 times 27 plus 10.771. But again, that's just a lot of extra work when we already have the model in Y1. This is why it's worth it to take a second to put this into Y1 and work from there. Okay. Next, it asks us, when does the model predict the percent to be 22.96? So 22.96 is going to be our Y value here. Okay. And so this is going to be where the calculator is handy again. If I go and do my zoom stat again, I can see my scatter plot and my equation. And what I'm going to do is I'm going to draw a horizontal line across this 22.96. I'm going to use the technology to help. Again, we could, if we wanted to, just put this 22.96 in over here. Whoops, sorry. 0.508 X plus 10.771, and then solve that for X. So it's not that hard to do this by hand, but we want to start getting comfortable with using the technology for these kinds of things. So what I'm going to do is I'm going to go into Y equals, and I'm just going to draw a horizontal line across 22.96. Okay. And if I look back at my graph, there's my original function. There's that horizontal line that I've drawn. This point where these two graphs cross is the solution to this problem. So the calculator is very, very good at finding these points where two equations cross. So all I'm going to do here is I'm going to go into the calc menu. So second trace, and I'm just going to find the intersection between these 2 points. So choose option 5 here. Okay, so first it's going to ask me, give me some instructions down here. I'm just going to follow them. First one says first curve. You'll notice that at the top it has Y1 selected. So that's fine. I'll just hit enter on Y1 there. Second curve, it has Y2 selected at the top. And then it asks for a guess. There's only one intersection point, so I could hit enter again, and we've got our answer. So 23.99 rounded to the nearest year means 2024. Okay, so you can certainly do this by hand. And if that's more comfortable for you, then go for it. But I would recommend starting to get comfortable with using your calculator to work through these kinds of problems, because once you've practiced a little bit, this is much, much quicker, much easier, and much more accurate, especially when our functions get more complicated later. With linear functions, sure, solving them by hand is perfectly reasonable. But once we get to quadratic, cubic, more complicated functions later in the course, we're really going to need to use the technology. It's important to start to get comfortable with that. Okay, so hopefully that's helpful with getting you started on this 2.2 section. Please don't hesitate to let me know if you have any questions at all.